Okay, now let's continue building of 1D geomechanical model. And now we will continue and go to step number 4, pore pressure calculation. The pore pressure calculation based on Eaton's method that consists of overburden gradient that we calculated on previous step, hydrostatic pore pressure, and acoustic logging. Yes, this is scheme show how this method works. It's based on normal compaction of clays, and under compaction zones consist abnormal pore pressure. Yes. So we will create a normal compaction trend, and on base this normal compaction trend we will calculate pore pressure by this formula. Okay, now let's open Geomechanics tab and Shale line. But before we will make Shale line, please create new well section, show the gamma ray logging on this section, and make minimum and maximum from 0 to 20. Yes, and now we will divide this curve on clays and sands. Yes. Please note that the divided on clays and sands we will show coarse. So now we will drive curve that will be divided. On left we will consider that there is sands, and right we will consider that this clays. Okay, this is very coarse. Let name it Shale line gamma ray. Okay, then open Shale line master. That as an shale identification curve we will select gamma ray. At base curve we will take DTP and assumed shale border line. This is shale line gamma ray. At output data we will get shale points and shale line. Shale points DT and shale line DT. Then okay. Now let's make visualization of points. This is shale points that accord right part of this border. We see shale points only where gamma ray more than shale line where clays, and we don't see shale points where we got the sand. Okay, now this shale line DT curve will be base for calculation of pore pressure. And for convenience, I prefer make filtration, data smoothing of this curve. Let's select shale line DT and smoothing. Let's make exponential arithmetic moving average by 101 points. Okay. Yes. Please note that we got more smoothed curve, and it looks more physically for calculation of pore pressure than initial shale line curve. Okay. Don't forget to save. And now we will make normal compaction trend line. Normal compaction trend line. This is dotted blue line. And under compaction curve, it is shale line DT filter. Yeah. To calculate normal compaction trend line, open the normal compaction trend master and use least squares method. As in base curve, let's do shale line DT filter. And I prefer check coefficients of linear, square and log curve and log trends. Okay, for linear we estimate as 0.77. Square, the coefficient is more than previous, and log, so equal. Let's use square. We set curve name NKTL normal compaction trend line DT, and output curve is microsecond per meter, and run. Okay, let's check. Okay, this is good. Let's make a logarithmic and backward scale for convenience and remove initial shale line. Yeah. Please note that black curve is a normal compaction trend line and red curve is initial. Okay, don't forget to save.